Hello everyone and welcome to 8.1 Similar Polygons. The warm-up question today is to share a cool scar story that you have with a neighbor. So today we're looking at similar polygons, and in class we did a Desmos activity to kind of investigate what similar meant versus what congruence means. And so the two properties we took away from that is that similar polygons has corresponding angles. All of the corresponding angles are still going to be congruent to each other, just like they were in congruent polygons. However, the corresponding sides are no longer going to be congruent. Those corresponding sides are going to be proportional to each other. So it's like in dilations when we did transformations. You might be making a shape either bigger by a scale factor, or you might be making a shape smaller by a scale factor, but the angles stay the same. The side lengths are all going to change proportionally. And so this statement is very, very similar to our congruent statement, but now instead of it saying these are congruent, these two polygons are congruent, this means the ABCD is similar to polygon EFGH. So here's ABCD. This first one right here, this is shape 1. Here is shape 2. So from this, we know that angle A is going to be congruent to angle E. And you can see that, not only can you see that in the picture, here's angle A, here's angle E, but we can also see that in the similarity statement. So A and E are in the same position. They're both listed first. We also know that angle B is going to be congruent to angle F, listed second. We know that in green, angle C is going to be congruent to angle G. And you can see those marked. This has 2 marks, this has 2 marks as well, so C and G. And then last but not least, those right angles, angle D is going to be congruent, that's listed fourth, to angle H, and both of those are right angles. So all of these angles, this is going to be for property 1, all of these angles are still going to be congruent to each other. However, the sides are not going to be congruent to each other. The sides are going to be proportional to each other in the way that they relate to each other. So let's look at this. Who would go with side AB? So that's going to be the first two, AB. So who is going to be in the same ratio as AB? AB is this side length here, and so that is going to go from E to F. E to F. So it's not the same side length, but we're going to look at the ratios in a second and how they compare to each other. So AB to EF, okay? So that's first two and first two. Now let's go last two and last two. CD over GH. Now let's go the middle two, BC, side BC, and middle two, FG. And last but not least, the outside two, AD would compare to EH. Okay, so now let's actually fill in those pieces, and I'm going to do this in some colors to kind of help you out. So AB is in the same position as EF, and so we're going to fill in the numbers there. So let's fill that in. That would be 6 over 12. Okay, let's change colors again. Here's BC, here's FG, so that's going to be 5.4 over 10.8. Since these are facing the same way, I can kind of talk about their positions. This is the bottom 4 and the bottom 8. So 4 over 8. And AD over EH, let's bring it home. AD is here, EH is here. So that's going to be 5 over 10. And so while it looks like all of these are different values as of now, 6 over 12, 5.4 over 10.8, 4 over 8, and 5 over 10, we know that for it to be a ratio, we need to fully simplify those. So all of these, when you reduce them, are going to reduce to 1/2. And here's what that means. All of these sides are proportional to each other from the second shape to the first shape. So I'm going to give this a green check mark. Since all of these are 1/2, that means that these are similar to each other, which we already knew since they gave us a similarity statement, but that's just verifying it. So if we wanted to do the scale factor of ABCD, which is the old shape, to EFGH, to the new shape, we would say that that is going to be old over new, or new over old. We always want the new iPhone over the old iPhone. Okay, so you're going to do a new piece over the old piece to find a scale factor, new over old, since I'm going from ABCD to EFGH. We know that that's getting bigger, so that should be a value bigger than 2. So I'm just going to pick a piece. I might go like 12 over 6. 12 over 6 is 2 over 1, so that is 2 times. The second shape is 2 times the amount of the first shape's side lengths, which makes sense because looking at this 1 over 2 over here, it's just the reverse of that. Going from left to right, it's getting bigger, so that's 2 over 1. So if you reverse that, going from right to left, going from 2 to 1, that is going to be 1 over 2. 1 over 2. So if I went the opposite way, that would be the old one would be EFGH. So if I went backwards and went this way, it'd be getting smaller. And so I could find pieces. I could go, okay, 6 over 12, and this would be the new piece. 6 over 12 is 1/2. Okay, so if I'm going left to right, I'd say that that's double going from left to right. If I'm going from right to left, we'd say that that's half. So you can just use that scale factor, and you can do the inverse of it if you switch the directions that you're going. All right, it says directions determine whether the figures are similar. So what we're asking is, are they similar? So we're asking ourselves, are these two figures similar to each other? That's what we're checking for. If they are similar, write the similarity statement in the scale factor. And it does make a note that the old is the one on the left and the new is the one on the right. So let's go ahead and put that in our picture. This one is going to be old, this one's going to be new. So immediately I know that if they are similar, it's getting smaller, so my scale factor should be less than 1. Okay? So the first thing you're going to do is you're going to check all the angles. Check the angles first. See if the angles are not congruent between these two shapes, then boom, you know that they're not similar. You don't have to check anything with the sides. So all of these angles appear in both shapes. So the first thing I've checked does work. The angles are congruent. Angles are congruent. Yes, that's a check. If not, I'd stop there and say not similar. But now I need to check to see if the sides are proportional. And so when I do that, I'm going to check the corresponding pieces. So we're going to see 12 over 18 reduces to 2/3. 12 and 18 are in the same position. Let's see, 8, and we want to go new over old. So 8 over 12, those are in the same position. 8 over 12. That reduces to 2/3. Let's keep going. 16 is the new, 24 is the old, so 16 over 24. That reduces to 2/3. Again, you can do this in your calculator. You do not have to do this in your head if you don't want to. And then new over old would be 16 over 24, which also reduces to 2/3. Since all of these sides reduce to 2/3, that means that this shape, these side lengths are changing proportionally. And so the similarity statement, they are similar. So it depends how you name the first one, let's say you just went D-E-G-H, D-E-G-H, we would say is similar to, you started here and went around the clock. So we're going to do that same thing, P-L-Q-R, P-L-Q-R. So those shapes are in fact similar, and their scale factor, new over old, would be 2/3. All of these reduce to 2/3, so they are similar. All right. This next one is a little bit tricky because they're not facing the same way like on my last one. And so the first thing I want you to do is recognize that these are both rectangles. And because it's a rectangle and not a square, there's the length and the width are different. And so on this shape, 10 is the smaller piece and 15 is the larger piece. So I'm going to color code that. So on my other rectangle, I always do this. What's the smaller piece? It's the 15, and the longer piece is the 20. So when I'm putting them together, I need to put purple with purple and blue with blue. I need to compare the pieces that go together. And so the first thing I'm going to do is check for my angles. Are the angles congruent? Well, because they're both rectangles, angles congruent, question mark. Since they're both rectangles, all 4 of these are right angles, and all 4 of these are right angles. So yes, the angles are in fact congruent. So now I get to keep going. Now I want to check the sides. So who compares with the 10, the smaller piece of the left rectangle? We actually want to go new over old, so let me do that differently. 15 over 10, because it says that the one on the left is the old one, the one on the right is the new one, and we always want the new iPhone over the old iPhone. This should show that it's growing. So 15 over 10 reduces to 3/2. Now let's check the blue pieces. New over old would be 20 over 15. 20 over 15 is going to be, divide those both by 5, that's going to be 4/3. Well, since one of them reduces to 3/2 and the other one reduces to 4/3, we know that those sides are not changing proportionally. Since these are not the same, there is no similarity statement because they are not similar. That's not being changed proportionally. They're not similar, and so there's not going to be a scale factor associated. So because these two fractions did not match like they did last time, we'd have to check. We're only checking 2 pieces instead of 4 because it's a rectangle. I know that both of these pieces would be 20, both would be 15, both would be 10, both would be 15. But because those fractions didn't match, we're going to say that these are not similar shapes. They're both rectangles, but they're not similar to each other. All right. Now, what's interesting on this next part is they give you the similarity statement. So we start by knowing that they're similar to each other. So we know that these shapes are going to be similar to each other. And we want to find the missing values. So first we want to find the scale factor of ABC to DEF. ABC is the one on the left, DEF is the one on the right. So we want to go new over old. So this will be our new, this will be our old. So new over old to find our scale factor. So we're going to pick a piece of the new and then pick the corresponding piece to the old. So here's my side length. Since we know that they're similar, 12 is going to correspond with the 16. If you weren't sure, 12 goes with EF, that's the second and then the third letter. BC goes with the second and then the third letter, which is 16. So I'd be able to do that by looking at the statement or by looking at the picture. So that is going to be 12 over 16, which makes sense as a scale factor because this is in fact getting smaller. 12 over 16 would give me a 3/4 scale factor, which means that this going from left to right, that's getting 3/4 the size. So what would be the reverse of that? Going from new to old, that would be 4/3. I don't even have to do the math, I just know that that's going to be 4/3. Okay, so it's just the reverse of the fraction. Going from right back to left would be 4/3 the amount, or 1 1/3. Okay, so how do we find missing pieces? The first thing I want to do is acknowledge that all of the angles should be the same. So if this is 82, who corresponds with 82? Angle D. Angle D corresponds with angle A, that's listed first. So I get to copy an 82 there as well. I always just copy my angles across. And then the 34 degrees is here. That's also going to be happening at F. That is listed as F and C. That's listed third. And so I can use my little bit of math, the triangle angle sum theorem, to do 180 minus what I've already used, minus 82, minus 34. And I have a total of 64 degrees left for angle B, which also means that 64 degrees is going to be angle E. So the first thing I'm going to do is fill in my angles. What is angle B? It was also 64. What is angle E? Angle E was also 64, because B and E are going to be congruent. And then what was angle F? Angle F is 34 degrees. And then what was angle A? Angle A was also 82. That helps show me I know that these shapes are similar. So immediately all of those angles must be congruent. Now we can use the purple pieces that are listed, or the scale factor, either way, to find unknown pieces. So who corresponds to X? That would be the 6. And then who corresponds to Y? That would be the 15. Okay? And so what I'm going to do is I'm going to set up a proportion by saying, okay, the way that 12 relates to 16 should be the same way that the 6 relates to the X. I'm going new over old. I'm going to go from the first shape to the second shape. Okay, so then I'm just going to cross multiply. And when I cross multiply, I'm going to do 16 times 6, which is 96, should be equal to 12x. And then I divide by 12 on both sides. And so X is going to have a value of 8. Always go fill that in the picture, make sure that makes sense. Check yourself before you wreck yourself. So yes, X is going to have a value of 8. Okay, let's do that again. Let's use the 12 over the 16 to find the red pieces. The same way that 12 relates to 16, purple to purple, should be the same way as we went right to left. So 12 over 16 should be the same way that 15 relates to Y. So again, I'm just going to cross multiply. 16 times 15 is 240. So if 240 equals 2y, or 12y, I'm going to divide by 12 on both sides, and I get that y equals 20. Go put that in the picture and make sure that it makes sense. 20 and y. Yes, so y is going to have a value of 20. Y equals 20. That's the longest side in that triangle, so it should be bigger than the 16 and the 8, which it is. Last two, now anytime you have an overlapping triangle, I make myself highlight just to show the pieces that go together. This is a little baby triangle, and then this is the bigger triangle, so they're overlapped, they're on top of each other. So the Y is this full amount, the X is this full amount. The 12.5 goes here. That's the entire big side of that triangle. The 5 goes with the biggest side of that triangle. So I'm not necessarily going to call it a hypotenuse simply because I don't know that that's a right angle, but now I see green corresponds to pink. So we are told from the very beginning that triangle ABC is congruent to, or not congruent, I'm sorry. This means, pause and slow down. This means that these are similar. We are told that these are similar, and so because we are told that they are similar, I'm able to find unknown pieces. So here's what I'm going to do first. I'm going to change to a different color, and I want to kind of color code. I know that the 12.5, let me see if I can make this smaller. I know that the 12.5 is the biggest piece of the green triangle, so that's going to correspond with the 5. So the way that 12.5 relates to 5 should be the same way that the larger piece, Y, relates to the smaller piece, 3. So equals y over 3. And now I just get to cross multiply. So when I do that, 12.5 times 3 is 37.5 divided by 5 gives me 7.5. So y equals 7.5. So I was able to find that green piece by doing blue over blue equals big green over big green. So let's do that again, blue over blue. So since I went big to small, I need to go big to small again. That is going to be equal to the big yellow over the smaller yellow. So that's going to be equal to x over 4. And so when I cross multiply, 12.5 times 4 is 50, divided by 5 gives me 10. Gives me 10, which makes sense in regards to the picture because it goes from 4 to 10, that does get bigger, and then from 3 to 7.5, that does get bigger as well. So we were able to find unknown values given that the shapes are similar. So same thing here. These two triangles are similar to each other. So since they are similar to each other, we know that all of the angles should be congruent, and we know that all of the sides should be proportional. So the first thing I do is I go small, medium, large. This is the smallest piece of the triangle on the left. So what's the smallest piece of the triangle on the right? AD. If you weren't sure, because sometimes it's hard to tell, BC is second and then third. Let me change colors. BC is second and then third, so that should correspond to DE, which is also going to be, so I need to change that actually. That my eyes played a trick on me there. So now you can see why we need to do this. 10 is the smallest piece between 10, 12, and 15. So let's go slow. 10, 12, and 15. My eyes deceived me here, and this picture might not be drawn to scale. It's hard to tell what the smallest piece is because there's two variables and a number. So I can't necessarily tell just looking at the numbers. And so what I'm going to do is I'm going to say, okay, well, BC is this piece, which is second and then third. So that should correspond with DE, which is second and then third. So the 10 is actually going to correspond to the Y. That's why we always have to check this. So your statement, let me go back to blue. Your similarity statement is going to be way more reliable than your picture. So the two blues should correspond, okay? Now let's go change colors again. 12 is my medium piece. That's BA. BA is third and then second. So what's third and then second? That goes with DA. So that's the 4. So the 12 and the 4 will correspond. Let me change colors one more time. CA is the 15, which is my largest piece, third and then first. EA should correspond to that. So yellow corresponds to yellow, blue corresponds to blue, and then the pink corresponds to the pink. So what are the only ones that both have numbers? The 12 and the 4. So I'm going to go 12 over, 12 over 4 should be equal to the same way that, I went 12 over 4, so left and right, that 15 relates to X. And then you could do that again. 12 over 4 should be the same way I went left to right, that 10 relates to Y. You would cross multiply and you'd get 3.3 repeating for Y. And then for your X value, you would get 5. All right, y'all's homework is on the back. So try that and we will check that tomorrow.